Tổng kết lại nhé, cái quá trình hoạt động của con DRAM này. Thời điểm mà bắt đầu mất điện mà nó chuyển sang cái số màu đỏ kia sau cái số 1 kia, thì từ cái phần này từ cái thời điểm này đến thời điểm này là cái việc xả năng lượng của con cấp linh. Từ thời điểm này, cái thời điểm mà xả năng lượng là cái thời điểm mà động cơ diesel sẽ chạy được 0-1500 vòng. Thì còn từ thời điểm này đến thời điểm này là cái thời điểm mà mặc dù ấy là đến đây ấy, cái máy phát cái động cơ diesel đã đạt 1500 vòng trên phút rồi, nhưng mà nó vẫn chưa đảm nhận được toàn bộ tải. Thế cho nên ấy, cái nguồn điện từ phần đây đến đây tải nó sẽ tiêu từ hai nguồn, là một cái con cấp linh cái con máy gà và cái hai máy phát. Đến từ thời điểm này đến thời điểm này là cái thời điểm mà cái động cơ diesel ở ngoài nó đã fully, tức là nó đã đảm nhận được toàn bộ tải. Thì trong cái thời điểm này ấy, thì nó chỉ dùng mỗi cái con động cơ diesel thôi, động cơ diesel. Đến thời điểm này thì động cơ diesel nó sẽ cấp điện để nó chạy cái bánh đà lên, đồng thời nó vừa cấp điện ra tải. Và đến thời điểm này là cái thời điểm mà động cơ diesel nó chỉ cấp điện cho cái phần tải bên ngoài, và đồng thời nó cũng cấp một ít điện để duy trì cái con bánh đà, đúng không? Sau đó thì giả sử cái thời điểm này là cái thời điểm mà mình có điện trở lại, hoặc là trước đấy có điện trở lại, đừng biết, nhưng mà thời điểm này là con Q1 nó sẽ đóng lại. Thì khi con Q1 nó đóng lại thì mất thời gian 3 phút là máy chạy không tải. Mọi người nhìn này nó hơi dưới cái đường đỏ này, có nghĩa là gì? Lúc đấy cái điện mà cái tải mình lấy là lấy từ điện lưới, và cái con động cơ diesel của mình trong thời gian 3 phút đấy là dầu nó sẽ tiêu thụ rất ít, mặc dù cái tốc độ của nó vẫn là 1500 vòng, 450, giảm hơn rồi. Cái thời gian cooling down mà chắc là 150 này. Thì lúc đấy mọi người hiểu là tải nó sẽ lấy là từ điện lưới chứ không phải là từ con diesel. Và đến đây thì bắt đầu là sau 3 phút thì bắt đầu là nó tắt động cơ, lúc đấy là nó fully. Đến thời điểm này nó đã fully chuyển ra cho lưới rồi, 1450 là cooling down.
Yeah. Come on, a little bit. Look at the UPS system. We only look at the UPS unit. PGM work together with induction coupling, diesel engine for the transfer or filter. And now like auxiliary equipment. Show a picture here of a UPS room. Many units work together. What you can see is, of course, in the engine room, it's like a exhaust, just like all the additional components of the UPS system. So we looked at the PGM, diesel engine, induction coupling, and generator. But to connect it to the diesel engine, you have the exhaust system, you have the cooling system, you have the fuel system. So in the room, in your system, there are more components than we only discussed this morning. So that's why later I want to go to the site and we will point at the different components. So here already then, fuel system, cooling system, exhaust system. So if you look at these components, sub-components they call it, of UPS system, PGM there, induction coupling, free wheel clutch and a generator, and diesel engine, we already discussed. Choke coil, you know, this one works together with the generator for the filter. But then also, of course, Q1, Q2, Q3, they don't hang in the air, they put in a panel, switch gear, your main power board. Switch gear, we will see. Components for the diesel engine, the cooling system, radiator, of course you need cooling, so your car. What they don't show here is the fuel system, also the engine needs the fuel. And also very important for engine is air, so we need air inlet, free flow of air filter you see here. So then inside then the control system for the UPS itself, we see here, but we see this old side there is with analog meters. Later there will be a picture about an HMI. So the control panel, And inside the control panel there is our controller. Monitor the mains, regulate the speed of the diesel engine, also regulate the DC braking current by this component. Tycon, digital controller. So diesel engine start. What components we can find in the system to improve the diesel engine start? It needs to ramp up. Then we talk about 2.5 seconds. Here it says 1.2, 2.5. And it needs to deliver the full power within 5 seconds. The transfer, I told you also in a discussion 1 hour ago, the transfer is 5 seconds. After 5 seconds, the diesel engine needs to take care of the load. So what we add to the diesel engine to improve the starting is a preheater. We will already heat up the engine. Even when standing still for weeks, it is still at 55 degrees, 60 degrees Celsius. So it's hot already. You can almost not bear holding your hand. Preheater. Just a heating system with a pump circulating the water continuously. What we also do is we pump the lubrication oil from the sump of the engine, pump it to the top of the engine, so all the parts are lubricated. So at the start, it's very fast. Pre-lubrication. So it is ready for a very quick startup. Pre-lubrication, preheating. It's always there. This pump will, once every hour, it will run for 1 or 2 or 3 minutes. It depends on the engine type. Our control system will, on the pump, if you're there longer in the room or you just happen to be there when the pump starts, you can hear when it's running. We will look at it. Once every hour.
So in exhaust system we have also have a heating element.
Exhaust? No? In it?
Out, ongoing reheat.
Yeah, it is in the cooling water. Cooling water in the engine. So later you can put your hand on there, it's hot. Of course it's hot outside already, but the engine is even more hot. 55 degrees, 60 something. And a pump, lubrication on the engine. So more systems, more subsystems connected to the diesel engine. I highlighted already. Exhaust system. It's a gravity fed fuel system. So what they say is like a storage tank higher than the engine. So the gravity by natural flow, the fuel will flow to the engine. They call day tank. Possibly outside there's a bigger storage tank. If this day tank is like a half full, the system will refuel the daily storage tank. Filling from a boat tank. So then for starting options, of course every engine needs starting batteries, 24 volts batteries, but there are systems, it's all options, that you add more battery, or you add more starter motors, or you add a RSP system that they use AC, convert to DC, and apply to the starting motor in parallel to the batteries. All kind of subsystems you can add to the UPS to make sure the engine starts.
So basically, if I remove the battery, is the gas start right?
Yeah, I think they work together. But if the battery gets weak, there's still a transformer, providing 24 volts in parallel. Yeah.
So how about the starter motor? How many starter motor in our system?
No, M2U, I think they have 2. Yeah.
So how we can control 2? I mean, this time is start from that one, another time start from that one.
No, they all work in parallel.
Parallel.
Yeah.
If they one.
I think there's no redundancy there. No, they always work together.
Yeah. So if they one broken, still can start.
More, but it can start, but it will be slower. I don't know. I don't think there is a redundant. So it's not like I can take one off and everything is okay. There should be two. Yeah. So then I don't know for this system. I guess this RSP system is there. It's a panel.
Okay.
Can add the DSP.
Ở cái hệ thống của mình nhé, nó gọi là redundant battery, thì có nghĩa là gì? Nó vừa có nguồn battery 24V mọi người có thể nhìn thấy, và nó vừa dùng cái nguồn mà nó tự nó chỉnh lưu ở cái đầu kia vào. Thế cho nên vừa sau anh hỏi câu ấy là trên nguyên tắc là tao có thể vứt cái bình ắc quy đi thì máy của tao vẫn chạy được, có đúng không? Ok. Tại vì sao? Nếu mà mình không bình ắc quy thì vẫn có một cái nguồn chỉnh lưu từ cái đầu ra của nó, đúng không?
Cái này là option, không biết Nokia có mua không, họ
Để
là
mua thứ hai này redundant starter motor nhé, thì có nghĩa là ông bảo là nó có hai
motor
và hai cái động cơ mình gọi là củ đề đấy, hai cái củ đề nó sẽ hoạt động song song với nhau. Nếu giả sử trên nguyên tắc nếu mà một củ đề hỏng thì vẫn có thể đề được máy, hiểu chưa? Vẫn có thể đề được máy nhưng mà có cái tốc độ của nó có thể nó chậm đi. Đấy là cái hệ thống này. Ok.
Cooling system. Radiator. The radiator inside the engine room, so you can see the engine. They put the radiator next to the engine, but you have also designed that the radiator is outside the room. Let's say on top of the container or next to the container.
So
then the cooling water pipes will go outside, cooling there, and the water will come back. So it depends on the design.
So it's one radiator and it's one air cooling by coolant or
The engine is by coolant. Yeah.
Coolant.
Yeah.
So
sure.
we need to refill or check the coolant every.
Yeah. For rust. Yeah. This is part of maintenance. Yeah, right. Yeah. So what we need to for you guys for understanding that if the radiator is in the room, there are big fans there. They not only use for the engine cooling, they also use for the room cooling. Because what we understand now that our generator and our induction coupling are spinning 24 hours a day. Also the diesel engine is 55 degrees. So inside that container it will get hot. For the mechanical guys, you will get worried about bearing, about grease, about lubrication. They all get too hot. So we need to cool the room also 24 hours a day.
So we mean that in the normal running, DSM not run, but the fans
still, yeah. So we will see later about the design in the container, but most of the time they use the radiator fan like a 1x1. So in diesel operation, all the fans are running.
Yes.
But for room cooling, they will start 1x1.
But is there any inverter or something?
I guess there's an inverter, yeah. So then for engine running, they have like two functions. The fan is controlled for the engine based on the cooling water temperature. But if the engine is off, the fan gets a second function for room. So probably there's a room thermostat based on the room temperature. They will still control the fan speed to get the air through the room.
Mọi người thấy các ở đấy nó có hai cái quạt, thì thông thường con máy phát thông thường ấy thì cái quạt này nó chỉ chạy trong trường hợp mà con động cơ diesel nó quay thôi. Động cơ diesel tại vì sao? Nó phải làm mát mà, nó làm mát nước. Nhưng mà con đế của mình ấy thì hai cái quạt này ngoài chức năng mà nó giống với máy phát thì nó còn thêm cái chức năng là bình thường nó vẫn cứ chạy, nhưng mà tốc độ thì có thể phán đoán là nó sẽ khác đi. Tại vì sao? Nó còn phải làm mát cái phòng ở trong đấy. Tại vì trong đấy mình vẫn có cái con lắp linh máy phát nó chạy đúng không? Thì nó vẫn tỏa nhiệt trong đấy. Con quạt này trong chế độ hoạt động thông thường thì nó chạy. Đấy là cái yếu tố khác biệt giữa con máy phát thông thường và con đế lắp. Chú ý này.
Room cooling. So don't forget. Different than for a genset. Genset, when it's standing still, nothing. Don't care. Nothing running. Only when the engine starts running, the fan will blow. But this is different. Our UPS, how we all understand, generators are spinning, we need room cooling.
Thì vừa xong anh trai có giải thích với anh vừa nói cái khác biệt giữa cái máy phát thông thường và cái thằng này. Cái quạt máy phát thông thường thì nó chạy khi là máy phát nó chạy thôi, nhưng mà thằng này thì nó sẽ chạy.
About a freewheel clutch. We understand how there's a freewheel clutch. The shaft of the induction coupling and the diesel engine, in between is a freewheel clutch. So the engine can stand still even when the induction coupling, the shaft is spinning. The brand here is by Stieber, so we call it Stieber type. It's a fully mechanical device. There's no electronics, there are no pumps. Only mechanical. Yeah. There's only a picture doesn't show, but there are only some sensors there to measure the temperature of the oil and measure the temperature of the bearing. Because you can see this is the induction coupling, that side is the diesel engine. So this shaft is spinning all the time. That shaft is standing still most of the time. So here there is a bearing. In the bearing we monitor the temperature. We check for the condition of the bearing. If there's a failure, it will get hot and we need to shut down. So there's a sensor and there's a sensor for the oil there, you will see later. But again, it's a fully mechanical device. It's same as your bicycle. Yeah, exactly. There's also no electronics there. Yeah. If you spin faster than the rear wheel, you will drive. If you go slower, you will not drive, and the clutch will open.
Cái này cái coupling này nhá, giữa cái máy phát với lại giữa cái con máy đạp với lại cái động cơ diesel của mình ấy, nó giống như cái cá xe đạp ấy. Nó không trong cái này nó không có một tí gì phần điện cả. Điện đây nó chỉ có một cái sensor để đo dầu chứ, nhiệt độ dầu thôi. Còn cái này nó thuần túy là như là cái cá xe đạp của mình. Nếu như mà cái tốc độ của thằng động cơ diesel này mà lớn hơn so với lại cái tốc độ của cái thằng đỏ đỏ này, nó sẽ kéo cái thằng đỏ nhá. Nếu mà tốc độ mà lớn hơn thì nó sẽ kéo. Thế còn nếu mà tốc độ của thằng động cơ này mà nhỏ hơn thì là cái cá nó sẽ nhả ra, thì nó không, hai thằng nó sẽ không liên quan gì nhau nữa. Nó như là cái xích, như là cái lip xe đạp của mình, không có gì khác.
They have a simplified drawing here. They only show one roller. Like the outer ring is the one that is spinning. The inner ring is connected to the diesel engine. And you can see that if the diesel engine starts to drive, it will clamp. So in fact, there are many rollers here. A whole ring, a clamping ring. So this is a little bit simplified. It's not only like a one roller, but it's a mechanical device. And there's oil in there, and same as your car, splash around, lubricate. There's also no oil pumps.
Thực ra đây trên hình vẽ thì chỉ vẽ một cái gọi là một cái cá thôi, mình gọi là cái cá, nhá. Thế còn trên thực tế của nó thì có rất nhiều xung quanh này. Là cứ khi tốc độ của thằng này nó lớn hơn thì bắt đầu là cái cá này nó sẽ bật ra ngoài để nó khớp với cái thằng đỏ đỏ này. Còn nếu mà tốc độ mà bé hơn thằng đỏ thì hai thằng nó sẽ không.
How about the lifetime for that clutch?
5 years.
It's from 5 years after.
They say 5 years for the bearing,
yes,
both sides, 10 years for the clamping ring. So every 5 years you exchange, probably just like an exchange program. They take out yours and they put a refurbished one in.
Yes.
And after 10 years, they need to replace the rollers also.
And how about we do some proactive maintenance there? You already measure for the temperature of the bearing.
Yeah.
So we need some kind like a vibration for the bearing there.
Yeah, but vibration, I don't know if you see it. Normally they put on this one.
Yes, in this shaft only.
Yeah, this one because it's shaking a little bit. There's no vibration sensor there. They only measure the temperature. When there's friction,
yes,
the bearing has a problem. Friction also will increase the temperature. They will
yes,
monitor only by temperature.
Because I mean, if you wipe to the friction,
Yeah.
the bearing already damaged.
Yeah,
or
already,
some
yeah.
guy they change before it become damaged.
Yeah, okay, yeah.
So
We do on induction coupling, yes.
Yeah.
But most of the time, it's they have the, I don't know if DP consultant already have, they have a handheld vibration measurement.
Yes, we have a handheld.
Yeah, like a Schenk, the brand is Schenk.
Yes.
So every 3 months or every 6 months, they bring this device with a magnet,
And mount
they clip, and they measure it. So they will put as a maintenance tool. They will put in a database. So the vibrations can be measured and compared in time.
Yes, we had like a trending.
Yeah, trending. Yeah, exactly. Yeah. So we will, and also the induction coupling is part of that route. So if they bring this tool from the help desk in Holland, they get a instruction at which point they need to measure. So all over the world they use the same measurement point so they can compare. Also for this unit, they will use the same measurement points for all its lifetime, so they can compare the measurements.
So for the future, when I need so kind of information I can get from you, because we already had our device formatted to be about vibration.
But that orange one, you got a high-tech one, they're not different.
No, I mean in our company.
Yeah, your company, yeah.
Yes. So we just ask for some information what the amplitude.
Amplitude, yeah.
Amplitude and
Yeah.
the database and
But it's always like the amplitude doesn't tell too much. If like I said, high-tech uses a shank.
yes.
They use the database. They put in that device.
Yes.
So all the measurements, horizontal, vertical, axial, they are stored in a database.
Yes.
And in Holland, the guy can analyze in time.
Yes.
So if you have a different device, you can only use it, check the amplitude, because you don't use the database.
Yes.
So then the only thing you can do then is like a login. If you say like every month you go there,
Yes.
and for each point
Yeah.
you log it, you only check for amplitude, but you cannot analyze if there's a roller damage or
Right.
Yeah.
We have a software and to analyze on the
Yeah.
frequency on there.
Yeah.
But we need the kind of some information like that.
Yeah.
Where you can combine because it depends on the they do a many machine.
Yeah.
You have many kind. You had a
Did you see the commissioning engineer take that orange device to do the measurement?
yeah.
Yeah. They do it normal operation,
Yes.
engine stop.
Okay.
They do it diesel operation,
Yeah.
low load, half load, full load. So they have like 4 different conditions.
Yes.
When the unit is in 4 different operation modes, they take measurements. And I think every measurement is can be like 10, 30 points something. But that's the high-tech database. I don't know. I have a procedure. It shows the amplitude, but it doesn't tell too much.
Yeah, sure.
Yeah.
If you will pass the training, amplitude is a one part only.
Yeah.
And you must do many for the
Yeah,
analysis.
frequency analysis.
Yes,
Exactly.
yes.
Yeah.
And then you can know. But
Yeah. But you can always compare.
say the information, and then we have the depth.
Yeah.
Your database, and we can know the very
Yeah.
before it comes to time to.
You
check.
can do it on the side, and you say like, hey, high-tech, I think something is wrong.
Yeah.
And then probably they will come and analyze by themselves.
Okay.
High-tech engineers, you're a mechanical guy.
Yes.
High-tech engineers know here they show the bearings.
Okay.
Outer bearing, inner bearing. They exactly know how many rolls. So if one roller is broken, and you make one rotation
Yeah.
of 1,500 RPM, and they hear the frequency, they know already the roller is broken.
Yes, sure.
So,
Because you run in the at a high speed, it's
Yeah,
4,500.
Yeah, because they know what bearings are in there.
Yeah.
So I think for you on the side it will be difficult. Ken, they have the tool. The service team will have the tool for it.
My meaning we cooperate in order to get a more understand about this kind of thing. We have to build a same database.
Yeah. So maybe you can compare later then. And be done. It is not on the machine itself, it's a tool. They bring it.
Yes.
Touchscreen, human machine interface. Probably you will recognize. The touchscreen, the operator controller, is inside the unit control panel, UCP. It's one of the panels in your switch room. So here you can see they integrate with the main power board, Q1, Q2, Q3, and the choke. We will see later how it is located in your room. So control panel, main power board, URP, unit reactor panel. There's the choke. But in your system it can be different. Just an example.
So the
Quickie, and I think we finished.
chuyển này
Dạ.
quá.
Ở cái hình ở cái hình trước thì đã chỉ giới thiệu cho mấy bạn hiểu về cái mảng giao diện thôi.
Hai mai.
This is a recording.
Ra ngoài kia em chỉ cho nó.
Đây là cái ấy nhé, đây là cái sơ đồ mà thực tế nó chạy với lại 100% tải.
Remember the mode, normal operation, transfer to diesel operation. You can see here, this is an actual recording from the test field.
Yeah.
Number one, output voltage. We should not see any interruption. Output voltage should continue. Output frequency, number two. See there. This is a line called 50 Hertz. Remember in my example, it was a straight line, the red one. In real practice, of course, you will see a little bit deviation because we control the speed by DC. Number three, the mains voltage. This is the one, at this moment, we cut. Boom. Mains failure interruption. Number four is the diesel engine speed, 1500. And number five is the DC current at the induction coupling. This one here. So what we see now, 1 centimeter is 200 milliseconds. So probably here there's a deviation. There's a moment of the mains failure is 1, 2, 3, 4, 5. This is 1 second.
Yes, sure.
1, 2, 3, 4, 5. 2 seconds. Here.
Too fast.
Very fast. This is just an example. The engine start, you can see here, this is the starter motor. This is starting and here, boom, clutch, engage.
Yeah.
But now we know, during this period, the induction coupling need to do the work.
Yes.
So, you can see here, we open the Q1. Immediately the generator voltage will go down, because nobody is driving the shaft.
Yes.
So this one, the diesel engine, we know is slow, but here this is the DC, the magnetic force for induction coupling. Boom! I don't know how much, they don't say, but this can be the 400 amps. And then you see, already when you reach 400 amps, here look, the generated frequency go up already. He's really helping, but you see it's going up, so he will lower its speed, and there he is steady. Steady, 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 steady. Boom, until the free wheel clutch close. He's like, ah, I don't need to help you anymore. But, oh, surprise, diesel engine cannot take care. So the DC, first he drop a lot, because you can see also when the clutch engage, boom, the frequency will go up. It's like a mechanical guy, bang, the clutch close with a push, with a punch. And then here they work together. But still the DC need to help, because they need to charge the turbo, you need to control the throttle. But RPM stay the same, also the frequency stay the same. A little bit below the 50 Hz, but stable. Here they work together until finish. So this is like a transfer. So this maybe 1, 2, 3. So this is like 5 seconds. This is the transfer for normal operation to diesel operation, including, I show you how much DC there is for the magnetic force to retrieve the energy from the induction coupling.
Cái hình này nhé thì là cái hình biểu thị cho cái thời gian mà transfer từ cái khi điện mất và cho đến động cơ của nó transfer phân tải cho cái động cơ diesel. Thì mọi người có thể nhìn trong cái này cái động cơ của mình ấy, nó khởi động đến khoảng 2 giây. Thì trong thực tế thì 2 giây thì nó sẽ đạt đến tốc độ 1500 phút, và khi nó đạt đến tốc độ 1540 phút thì cái dòng cái từ